Okay, good morning everyone. My name is Nadia Smith. I'm BEKA Schréder's Senior Communications Officer. Welcome to our webinar. Thank you for joining us this morning. We look forward to presenting to you the solar lighting system with emphasis on battery technology. If you have any questions during the webinar, please type them into the question mark tab and we will answer them after the presentation. Please note that there are some brochures available for download in the handouts tab. Joining us this morning is France. She is the training project manager at Schréder, and she will assist us with this platform in the background. Most of us are presenting from home, so again, please excuse any unusual noises in the background. Grant Combrink, our marketing and segment development manager, will start off with a quick company overview. Gert Labuscagni, our technical solar specialist, will take you through the battery technology. And then Grant will finish off with battery calculations and highlight some marketing material that's available. As mentioned before, this will be followed by a Q&A session. And then finally, we will ask you to complete a short poll to give us feedback. I'm now handing over to Grant.
Good morning, everybody, and a warm welcome from me. I look forward to presenting to you today. I think it's really good to deep dive into the solar lighting system and really to empower us to understand the battery technology. So let's move ahead. It's always good to reflect on where we come from because it really paves the way of where we're going to in the future. One thing that we're really proud of is our African roots. And being in the industry now for 40+ years, it's really part of our heritage. Local for us is very important, as you can see with our 30+ staff and employees in the organization. Our local employment and empowerment of these people is very important to us. Also, with regards to our company ethos, is almost 2 decades now of being part of the Schréder Group, and this is really allowing us to be in the forefront of technology, manufacture, and development with regards to luminaires and all other lighting products and poles, of course. And this really ties in with the heritage because it really runs deep within the Schréder organization. Just some main fundamentals and added value that we pass on to our customers, and it's very important to the offering that we pass on to you is obviously the ISO standard. So it's not just a quality certification, it's really a whole holistic approach to the whole organization, not just with regards to processes, but product and the full offering that we do give to the customer. We are committed to the energy saving, but what we really want to focus, part of the energy saving today is sustainability. And you'll hear me continuously mention that because that's really what we want to drive home. One of our main added values and services we do offer, in the background, we've got a full R&D team that really drives the technology to make sure that we're giving a product to our customers that is really at the forefront of lighting design and the technology and upgrades with regards to lighting. And then attached to that, we've got a design team, an applications design team that really makes sure that whatever you are specifying with regards to lighting, we can really make sure that your application is illuminated correctly and to the correct standards in application. We do pride ourselves in full lighting solutions all the way through into different segments. Today we are going to focus on a road segment, more public spaces with regards to solar lighting. Let's just get into the sustainability side, which I'll mention in the next few slides. And one thing that we really got to remember, and we tend to forget a little bit with regards to lighting, is well-being and safety. You know, light has so many benefits, and we tend to forget that the safety that it does bring to certain areas. General light is well-being for a lot of people, and the sustainability around that in public places is very important to us from a whole holistic approach. And as you can see, we do have some very important organizations that agree with the statement, because we always have to look into the future. And that's why, as I mentioned earlier, you know, we reflect on the past, but we really have to make sure that we meet the needs of the future generations. Something that I just want to continue on with regards to the sustainability. Part of the sustainability and the offering that we do have is the specification, which is very important, and we will deep dive further into that now. And what you are illuminating, that is really important with regards to solar, because renewable energy and going off grid is only one aspect of this. We've got to remember that there's a whole bunch of components that we need to understand the specification of, and also importantly, what light is coming out of this unit. What application are we illuminating? So let's not forget, we've got this lovely form of sustainable energy, but attached to that is the specification and illumination. Just with regards to that, just to drill down a little bit deeper, part of this whole system, we've got light components. Each light component will have an efficiency, will have a certain output, which have a certain lifetime, which you've heard over and over again with regards to lighting components, useful life, rated life. So it's very important to understand all these building blocks. Another huge component for us is the mechanical part of the unit. How's the heat getting dissipated from these light components? You know, we pride ourselves with our marine grade aluminium for the heavy, and that's always an important consideration when you're looking at the specification. Something that we're going to highlight further today is the electrical component of the battery charge controller and PV, but we're going to focus on the battery today. So it's always good to understand, with regards to your capital cost, what are you investing in? And then again, we've got the added value where we do have some connectivity with regards to Bluetooth. We won't go into that too much today, but we do have that added value attached to this whole system, which is the solar unit itself. Okay, let's go into some essential terms that we really need to know. Like I said, it's going to be an analytical view of this whole system, and we're going to deep dive into batteries. So one of the main terms is battery autonomy. So also known as backup or discharge time. The autonomy is a measure of time in which the battery will support the critical load or rainy days. Autonomy is a function of the battery charge state, capacity, and load size. Okay, another very important fact, an essential term to know, is the depth of discharge. And you'll see later on, I'll show a graphical view. We sometimes refer to this as a reserve tank. We don't want to get into this depth of discharge, because that can affect the battery in a certain way. So it's very important to understand what battery is selected, the amount of cycles that is attached to this battery, and what is the depth of discharge you can go to with regards to this. And it's a very, very important factor to how we're sizing the battery itself. Gert, would you like to deep dive into some of these advantages and disadvantages?
Thanks, Grant. Hello, everyone from my side. Well, I'm going to take us through all the different battery technologies that we offer to our clients at the moment. I'm going to start off with the one that's probably the best known in the industry, which is your LED AGM battery. For those of you who are not aware, AGM stands for absorbent glass matte battery. It's basically just like a little absorbent mat inside the battery that absorbs the gel, that gives you longer life expectancies, and especially good for deep cycling your battery. So this is a very a battery that's used quite broadly around solar systems. So the one advantage of this type of technology, it's been around for more than 30 years. So this technology is very stable, it's very safe, and there's very low risk of any fires or things like that on your systems. This technology is also quite cheap when you're purchasing your system. So yeah, it's one of your cheapest technology you've got out there. Saying that, it's also quite available, so you have short lead times when we need to procure this product. Some of the disadvantages of this technology, AGM batteries are quite heavy, so this makes it quite difficult to install on site. Takes a lot of effort and special equipment, especially to install this. So you're also very limited on your operational temperatures. You're looking at between 50 degrees Celsius to 60 degrees Celsius. Now, this is quite important when you are on site, especially places like the Northern Cape, where environmental temperatures in the rural areas can get quite high. So you always need to take this into account when selecting your technology, that your battery doesn't degrade because of the environmental temperatures. Saying that, one must also remember that these batteries have an expected life of between 3 and 5 years, which amounts to about 1,200 to 2,000 cycles. And this is quite a broad range, and this is mostly dependent on your environmental conditions on your site. Whereas if the conditions are quite harsh, you might end up with a lower spectrum of your cycles. But if the environments are very favorable and you do not have a lot of rainy days, for example, you will tend to go to the higher spectrum of your life expectancy of the battery. Of course, these batteries have a limited charge capacity of 20 amps, and this basically means the rate at which we can actually charge the battery at is limited to 20 amps. So we do not want to exceed that. Of course, if you do, you will damage the battery and ultimately the system and lifetime of your battery. And we only have a limited 1-year warranty on these batteries from our suppliers. Thanks, Grant. Right, then something that everyone is hearing a lot about out there is lithium technology. Now, lithium is quite broad. You get quite a few different chemistries on this. The chemistry that we use is a lithium manganese oxide, which has been around since 1996, so it's quite well known. Advantages of lithium batteries, of course, they have a very higher power to mass ratio than your AGM technology, which makes it very nice in terms of weight when it comes to installing these systems. This means, of course, that the pack is much lighter. It's easier to install on your site. And because these batteries are made up of cells, you can manipulate the shape and size of it, which makes them quite flexible in terms of their shape, and you can actually integrate them into units quite easier. And that is where you start seeing these new integrated systems in the market. Another nice advantage of them is they have a depth of discharge of 80% with a life expectancy of between 5 and 7 years, which amounts to 2,000 to 2,500 cycles. This, of course, is much better than what you get with the AGM battery. Now, to give you guys an example, if you were to reduce your depth of discharge to about 50%, you can achieve up to a 10-year life expectancy on these batteries. Normally, we design for the standard system for a 2-day autonomy at the 80% depth of discharge. So for a normal day, when your battery is cycled, we will only drain the battery up to a depth of discharge of 40% of its capacity. So that just gives you an idea of life expectancy on the system using this technology. These batteries, unfortunately, has a maximum charge rate of 15 amps, which is controlled with the integrated battery management system on the packs, which controls and safeguards your battery from being overcharged or over discharged. Unfortunately, all technologies have some disadvantages. Now, when it comes to lithium, the initial cost is quite higher than on your AGM battery. It has a similar temperature operational range of between 50 and 60 degrees Celsius. So one needs to take care where you install them, how you install them, your enclosures and things like that. And another disadvantage of them is they have a special charging algorithm that is different to what your lead AGM would be. So contrary to beliefs, you cannot necessarily exchange your lead AGM with a lithium battery. You will have to change the charging method onto the battery so you do not damage it, as lead batteries usually get a boost charge from time to time. And if you were to apply this to your lithium, it will basically destroy the battery. So it's very important to know that you are charging it at the correct rate. In terms of warranty, we get quite a substantial increase from what you will get with the lead. You get a 3-year limited warranty on these batteries. And then, unfortunately, these battery packs have a longer lead time than you would with the lead AGM, as they are specially assembled for a specific application. So what happens is when you order your system, we basically will get the pack made up, especially for that application, which unfortunately takes some time for the supplier to assemble everything together before supplying to us. So that gives you a slightly longer lead time on this technology. Then something new that we are quite excited about is your supercapacitor modules. This technology gives quite a few benefits, and we are very excited to have this technology as part of our range. Some advantages of supercapacitor modules is they have actually been designed for much higher temperature ratings of up to 80 degrees Celsius. So this means you can, with ease, install these into quite harsh environments like in the Northern Cape, etc., where environmental temperatures can get quite high. They also have a maximum charge rate of up to 35 amps. So this is the allowable current that you can charge it from your charge controller into the battery. So this allows you then to charge your battery up much faster than you would with the other technologies, which makes it much nicer in terms of what you need in terms of solar panels, etc. Then another nice feature of this technology, it's very similar in mass to a lithium, so it makes it much easier to install on site, and yeah, makes your system lighter. You can also look in terms of your pole to make things much cheaper there. Something that I enjoy about this technology is you have a 10-year operational warranty from the date of commission of your site, and an expected life of up to 45 years on this module. Another nice benefit of this module is you do not need to be worried about the depth of discharge of the system. You can actually use 100% of the capacity of this module without expecting any damage over the lifetime. So that's a very nice benefit for this system. Of course, some disadvantages. It has a higher initial cost, but remember, if you look at your life expectancy and warranty, your ROI or return on investment has a very big benefit. Unfortunately, at the moment, it's only suitable for our systems up to 53 watts, which is 8,244 lumen system. And this is only due to the commercial availability on the sizes of these packs. But I must admit, the range is being extended quite fast. We are seeing new things coming in there, and the power to mass ratio of these units going up quite extensively in the future. So just to summarize for everyone, yes, we've got a nice summary sheet of all three technologies that we offer, your lead, your lithium, and your supercapacitors. Just some things to highlight. Of course, the maximum date of discharge for your lead battery is only 50%, your lithium being 80%, and your supercapacitor module up to 100%. Then if one looks at the cell operational temperatures, lead going from -20 up to 50, sometimes 70. We have an option for harsh environments where you can select a battery for up to 70 degrees Celsius. We like to use these modules in more harsh environments like in the Northern Cape. Then on your lithium side, unfortunately from between -50 up to 50 degrees Celsius, so these modules have a limit in terms of the temperature rating, and if one were to use them in more harsh environments, this affects the life expectancy, of course. And then our newest supercapacitor can go up to 80 degrees Celsius with any problems. Then if you just look at your projected life expectancy, lead batteries around 2,000 cycles, lithium 3,600, and supercapacitors can have between 20,000 up to 1 million cycles. Now, the reason why this is quite broad is that there has been some people out there on the lithium side testing our modules, and they have claimed that they only get up to 20,000 cycles on these units and not the full 1 million cycles. But as you can see, in my personal opinion, 20,000 cycles, it's way more than your 3,600. So in any way, if you achieve your 20,000, you have surely, in my mind, exceeded the life expectancy of any lithium or lead battery out there. Just in terms of predicted life, lead, of course, between 3 and 5, lithium 6 to 8, and our supercapacitor up to 45 years of life expectancy. If we were to look at shelf life of these units, lead battery, you are only expected to get about 18 months of shelf life. This is the life that it can stay on the shelf before you basically lose some of the capacity. Now, the lead, of course, needs to be recharged every 3 to 4 months to be able to keep the charge of the system and not to damage it. Whereas the lithium, you can keep it on the shelf for up to 3 years. And supercapacitors, we can keep up to 10 years on the shelf with any damage. We do not really need to recharge them. Yes, they do have a discharge rate on the shelf, but as they are capable of being discharged up to 100% of the capacity, if the battery were to run completely flat, you will not lose capacity when you recharge it, when you want to install it on the site. Then just if we would look at the weight of these modules, lead, of course, quite heavy, Because of the lead inside, you're looking at about 30 kilograms for a 100 ampere hour module. Lithium, quite flexible. Depending on your system, it can be anything between 3 kilograms to 12 kilograms on a battery there. And the supercapacitor is a standard size module is 8 kilograms. So that just gives you an idea in terms of weight. If you compare it to a lithium, it's nicely in the middle there of terms of weight. So it's quite an easy thing to move around and handle by yourself. Of course, what everyone would like to know is how do these modules compare in terms of price. So here what we've done is we've just done an average cost comparison. If one would have to use a 100 ampere hour lead battery, if one would say that is a price battery, your lithium can be up to 2.5 times the price of a lead AGM. This of course depends on the capacity, but we've now looking at a 100 ampere hour version, and your supercapacitor will be about 3 times that of a lead battery. So when it comes to the supercapacitor, I always like to rather compare it to a lithium. You can see it's only about 0.5 times more expensive in terms of cost for this module, but your life expectancy is extremely much higher than what you would get with the lithium pack. So yeah, that's just a nice summary for us on the battery technologies. Thanks, Grant, for the opportunity.
Thank you, Gert. Okay, let's move on. Okay, so now to get to the interesting parts of the webinar. So if you'd like to have a piece of paper handy or a calculator, we can really start looking into how to calculate this, because we found there's a lot of specification out there, and they're giving you some specification with regards to all the components that I mentioned previously, but we really want to drill down now to actually do a quick check for yourself to make sure that the battery can support the load, because effectively you still want to have the illumination required for the application and to adhere to the certain specification that you're wanting to adhere to. So let's just go step by step. I'll do this as slowly as I can and give you a bit of a graphical representation of it. So what data do we need here? So first of all, we need to understand what the load is. This will be the power of the LED itself in wattage, the output power of the LED. Then we're looking at the rated working voltage of the LED from the battery. The LED output during the night at 100%, whatever that value is in hours, or if there's a specific dimming profile. Number 4, we'd look at the days of autonomy or rainy days, as mentioned previously. And then also very important, again, we need to know what type of battery and its depth of discharge. Okay, so just to drill down even more now, for example's sake, let's say we've got a 30 watt LED unit run by a 12 volt battery. We have a certain dimming profile here, 1 hour at 60%, 5 hours at 100%, and 3 hours at 80%. This will be your dimming profile over a nighttime period. So we assume at 100%, we calculate it through to give us 8 hours at 100%. Then we have 3 days autonomy or rainy days, and we're looking at a lithium battery here with a depth of discharge of 80%. Just purely for example's sake. So just as a graphical representation, if we have to see this as a bucket where current flows, and the building blocks of this, where we have a negative to positive charge of current flowing through this unit, and that little spout at the bottom is the flow of the current outside of this battery. We have the wattage, we have the voltage, obviously with terms of Ohm's law, that you can calculate the current from that. We have the hours, dimming profile, the length of time at 100% that this solar unit will be operating. We've got the days of autonomy, and then we've got the depth of discharge. And as you can see at the bottom, it's the depth of discharge because this is your reserve tank. You do not want to deplete any of the charge into this depth of discharge because that will reduce your cycles in the life of the battery. So this battery, this is the building blocks that you calculate the battery to, and it's all measured in amp hours. We have wattage and voltage to calculate the current. We've got the time or hours, autonomy, and the length of time that it's going to operate at 100% to give us the hours, and then we have the depth of discharge. Okay, let's get into the calculation. First of all, we apply Ohm's law, and we say power is equal to, obviously power is equal to voltage times current. Therefore, the current of this that is running through this unit, we're looking at 30 watts divided by 12 volts. Then, and that will give us a 2.5 amps. Now, it's very important as the sequence and the steps run that we remember the units involved here. So we said there was this unit will operate for 8 hours at 100% based on that dimming profile over the 12-hour period. So we take the 2.5 amps that we calculate, we times it by 8 hours, which gives us 20 amp hours. We then look at the days of autonomy. We said the 20 amp hour unit now has a day of autonomy of 3, so we times that through to give us 60 amp hours. Then we have to consider again the depth of discharge, because it's a lithium ion, it's 80%. Divide that by 0.8, the size of the battery is 75 amp hours to support the load of 30 watts for that period of 8 hours at 100% that you require that that LED solar system to illuminate. Okay, let's look at some real life calculations and some data. I've just taken some hypothetical situation here, but let's just bring that example into practice. We have a LED light source of 100 watt. We have a lithium battery, a 25.6 volt, 40 amp hour unit. This would be obviously a specification that comes through. We have a lumen output of 10,000 lumen. We have an operational period of 12 hours, 3 days autonomy. So based on this information, we always want to highlight, is this battery going to support the load? And is that load going to be sufficient to give us the illumination required for the application, which is obviously vital to the specification that is required, because we always want to make sure that we are compliant with regards to light level requirements. So let's just go into the calculation again. We apply Ohm's law, power divided by voltage. That will give us 3.9 amps. Now we just have to look at this calculation and think, well, hold on a second now. We've got a 12-hour period at 100%. So if we look at the daily consumption of this, we've got 3.9 amps times 12 hours gives us 46.8 amp hours. Now the battery capacity mentioned here is only 40 amp hours. Okay, let's carry on the calculation. We had 3 days autonomy. See that? Oh. We had 3 days autonomy. Looking at now 140 amp hours required load to support. Then we bring in the depth of discharge. And you can see the size of the battery that is required to support that 100 watt light source and give you the lumen output of 10,000 lumens. So effectively this battery should be 4.5 times the size at least. So this is where you should be concerned. Then we take a step back and say, there's a specific dimming profile that wasn't mentioned in the specification. We calculate that through and said, no, based on the dimming profile, it's only going to be operating for 4 hours at 100% brightness. So we go back to the calculation, the second step. We say 3.9 amps times by 4 hours is now giving us 15.6 amp hours. Okay, now we're getting there. Then straight away we bring in the days of autonomy. Again, and we bring in the depth of discharge, the battery is still too small. So really, when you're looking at a specification, it's good to do a quick calculation like that, just to understand that is the battery size going to support your load. And that is the biggest issue. So effectively, this 40 amp hour battery will not support this 100 watts nighttime duration and that autonomy. Okay, let's go into another specification or example. Let's look at a light source of 40 watts. We have a lithium ion battery of 12 volts, 60 amp hour, lumen output of 5,000 lumen, 7 hours operational time based on a dimming profile, 2 days autonomy. Okay. If we look at the dimming profile as represented here, we can, as we calculate through, we can see we've got, if you calculate base, easy way to do it as per school maths, you count on your fingers. Our 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8 is 6 hours at 50% is effectively 3. You've got 2 hours on either side between sunset and sunrise, which is 4. That gives us 7 hours operation at 100%. Okay. Again, we're highlighting battery size and the lumen output to make sure that we can support the load and get the illumination on the application that we require. Back to the calculation, Ohm's law, power divided by voltage gives us 3.3 amps. Bring in our 7 hours duration at 100%, 23.3 amp hours. 2 days autonomy, 46.6 amp hours. Depth of discharge, you can see this specific battery will be able to support the load of 40 watts at that lumen output. So effectively, that is a quick check that we can do to make sure that your specification and data that is being presented to you is correct with regards to the sizing of the battery. Okay, let's move on to the something that we're very proud of and that we launched last year is our BEKA Solar Gen 3 unit, and we really pioneered the way that we're empowering our customers to make a graphical representation of how to choose the correct solar system for your one location, how many days of autonomy you require, the specific battery technology, and as you can see, the icons that we've used through the presentation are represented in our brochure. We've given you a whole bunch of dimming profiles based on your application and need, and also with regards to the luminaires itself, the wattage, and the certain lumen output that is required there. So we're really pioneering the industry with this, and this was launched last year to really allow you to configure your solar unit to your needs. And you know, we're very proud to be able to drive this and empower our customers to be able to, you know, to make the correct choice with regards to the configuration for the application. Okay, I think we can push into our questions now. Nadia,
yes.
do you want to kick off?
Sure. So just as a reminder, if you've got a question, please type it into the question mark tab. We do have a question here. Oh, sorry. So
Nadia, before you ask the question, if there's any specific detail from this that you require, either for us to consult you personally or with one of your teams, please be in contact and we'll happily do this webinar or training specifically with your team. So just get a hold of us and we'll happily do that on a one-on-one session or on a specific group session. No problem. Sorry, Nadia.
Sure. Sorry, no problem. Okay, so the first question we've got, in terms of environmental issues, is there any recommendation about disposal?
Kat, I know that there's been some discussions around that. We do have obviously specific companies that will do any specific disposable of any lighting or componentry for us. So we can definitely consult you with that. But obviously there's definitely ways to dispose of that safely and environmentally safely. based on the sustainability that we require. Gert, I don't know if you want to add anything to that.
Yeah, I think just to add, remember lead AGM batteries can be handled as a normal lead battery. So those, of course, can be either usually be disposed of at your normal automotive battery center. We'll be more than willing to purchase it from you, as there's a lot of lead inside those units that get recycled and repurposed into new batteries to be remanufactured. On the lithium side, this is quite something new in South Africa. I think mostly the best would be is to consult with the guys on the computer side, as laptops use a lot of batteries. But of course, if you have struggles with this, you're more than welcome to contact us, and we can surely make use of our recycling people that do recycling on our side to assist you with the correct way forward.
Okay, good. Thank you. Then we've got another question here. What key items of the system need to be maintained? How often does one need to conduct maintenance of such an installation? What costs are then involved? And then lastly, what sort of performance lifetime reduction are we looking at when maintenance is not conducted? Do you want me to, shall we break this one up maybe?
Yeah, that's a good question. Gert, I don't know if you want to start off, and then I'll finish off there from more of a commercial side.
Yeah, no, sure. In terms of maintenance on the systems, I think the most important part, of course, is to keep the solar panel as clean as possible. Usually, for normal environments where there's not too much dust accumulation for the solar panel, one can look at cleaning them once a year maybe, just spray it off with some water, and it should be fine. If there's any debris in terms of from birds and things like that, one can just use a damp cloth to wipe it off. One should never use something like alcohol-based to clean the panels. Water is more than sufficient to clean them up. And I think just in terms of if one were not to maintain it, keeping the solar panels clean will reduce the charging of your batteries. And especially when it comes to lead and on the lithium side, your life expectancy on the battery will be reduced because the system will either run to the depth of discharge quicker. This results in not having enough battery capacity to run your luminaire for the complete night. Luckily, our charge controllers are sufficient enough to cut off the load to the luminaire when you have reached your depth of discharge. So we are trying to protect the batteries as much as possible. But of course, your luminaire will then, when you come there in the morning, the light will already be off and it will still be dark because your battery does not have capacity from the solar panel to charge it. So I think the most important part is to clean the solar panels.
I think there was also mentioned there, Gert, of the performance-wise. Obviously, the duration of the luminaire performing at 100% will reduce.
Yes.
If it's not maintained as mentioned.
Yeah. If you don't keep the panel clean, what will happen is your light will come on at night, and then early morning, when the battery did not receive its sufficient charge, your luminaire will shut down, which of course results in the site being dark, and you lose the benefit of the safety and of having the light on in that area.
Okay, I think hopefully that answered everything. Yep.
Then there's another question or a request. Please indicate the operational voltage of the systems indicated on page 10 on the configuration matrix. on the product brochure. Thank you.
Okay, just I can maybe just quickly answer that. That's maybe a good thing we could add. All our systems run on a 12-volt battery configuration. So that should answer that question.
Okay. Then can the battery or wattage sizes accommodate for a national roadway?
Yeah, so I can just quickly answer that. So if we're looking at the class of road specifically, lane-wise, we'll look at a 2-lane. It can handle any class B of road, up to a low end of A2, A3 and A4 for our ZEA2, the high lumen output unit. And just with regards to that, you're probably looking at a 6-meter mounting height spacing, depending on the output of the unit, anything from 25 to 40 meter spacing. But effectively, you're only looking really at a 2-lane. So any national double lane, etc., no. But obviously, as the technology improves and with regards to the capacity wise, this will be able to be extended. But that answered your question.
Great. Then the next one, please explain days of autonomy again.
Okay, so days of autonomy is effectively how many days you're not going to have sun to be able to charge the battery effectively. That's why we refer to it as rainy days or cloudy days. Yes, there is a little bit, and I'm sure Gert will want to come in here. Yes, there is a little bit of charge that you still get, but effectively to calculate the size of the battery, we always take into account if we had to look at weather patterns, how many effective days you do not have sun effectively. I don't know, Gert, if you want to add anything to that.
Yeah, at the moment, for depth of or for autonomy days, we are assuming 0 charge. This, of course, will be the worst case for condition. So we always prefer to have our batteries slightly oversized. So that is not necessary to get to the depth of discharge of the system. So we can extend the life of our battery and reduce maintenance. So like Ron said, yes, there is a slight charge, which we are taking into consideration, but we feel it much more beneficial to assume no charge on the battery to allow you to extend the life of your battery pack for the system.
Okay, thank you.
Okay.
Then here's the next one. An example of 30 watt and 40 watt sources. I'm worried because in real streetlight installations, you have more than 100 watt. That will raise the battery capacity and space will always, or space / land, I'm not quite sure about this one, will always be a challenge. Please comment.
So effectively, if we had to look at application-wise, if we had to look at any public spaces specifically, then we can get into a lower wattage unit. If you want to get into obviously the high wattage where we require specific road illumination and requirements, then yes, we'll push the lumen output as high as possible. But when we're talking lower wattages, it's obviously let's say paths, parks, plazas, that sort of application. Effectively, that's really the broadband of the application that can be adhered to with regards to that. But yes, we want to make sure that we get to the right illumination for the application. That's why I said for our high-end unit, the ZEA2 specifically, we can do up to a low-end A2 class of road, but mostly it will cover all Class B, some A3 and A4 roads.
Yeah, Yeah, so we do, or just to add to that, Grant, in our brochure, you will see we have an option of up to 80 watt output. With the new lumen to watt outputs, you are looking at around about 10,000 lumens on that unit. So for those higher end products, of course, to keep the battery sizes more manageable, we will apply a set dimming profile to that, so we can adhere to specification when you have higher traffic volumes, that as soon as it gets dark, you have 100% output on that unit, and then as the night gets quieter, you dim down to lower levels where you do not need such high levels of light output to save some battery life. And then as about 2 hours before sun up, when your traffic usually increases, that unit will go ramp up to 100% output to illuminate the area significantly more than in the dim profile, and give you the safety and the specification that you require without having to have these huge battery packs and units installed on site.
Okay, thanks. And here's the next one. Are there any restrictions shipping different battery technologies?
Yes, there is. Lithium, unfortunately, is seen as dangerous goods at the moment. So they can be transported by road. They are not allowed to be transported by air. At the moment, you really need very specific and stringent rules surrounding that. So yeah, I think lithium is the one that's most problematic to shipment, but in terms of lead and supercapacitors, they are free to be shipped with any means of transport at the moment.
Great, thanks. Then what is the impact on the system in terms of winter, summertime for charging? Is this taken into account during the calculation?
Yes, for sure. When we do our battery sizing, we look at, but especially on the solar side, is we are looking at the worst 3 months of charge during the winter, so that your solar panel is sized big enough. So for these 3 months, you will also get full charge during a normal day. And we also, if you look at the brochure, you'll see there's different inclination angles for each area to optimize the charging from the solar panel into the battery.
Okay, then we've got the next one here. Can these solar lights be stacked to provide higher lumen packages?
At the moment, we do offer one that you can, what we have on our design now is we can actually have 2 battery boxes and a double panel, which gives you the capability of having running 2 luminaires either side by side, or back to back, where you'll have a median application. So it is possible to run up to 2 80-watt luminaires from one pole.
Okay, thank you. Then we've got a comment here. So just a comment. Vandalism is currently a first enemy to this technology if installed in isolated sewage pump stations or far parts of the wastewater plants, in my case. I don't know if there's a comment regarding vandalism.
Yeah, just from I mean, we do know vandalism is something real that we face all the time. We can obviously we put in whatever, let's say, it's a difficult question to answer because it's real and it's part. But what we can do is there's many aspects with regards to securing the unit itself, and really to really not let any vandals actually come to the unit. we can, I think, let's rather consult you separately and take it offline. We do have vandal-proof screws, etc., but it gets to the point where if you know, if it's going to be vandalized and they want something in that unit, they will find a way to get it. But we do take any precaution necessarily, and we can obviously make sure that we secure the pole where nobody can actually get up there with regards to any sparks or anything specifically on the pole that we can add to that as an accessory, just to try and deter any vandals. I don't know if Kat, if you want to, it's always a difficult question to answer, but I don't know if you want to add anything there.
Yeah, just as Grant said, we try and use vandal-proof screws where possible on our system to make it much more difficult to open it. And we also have an accessory as a pole spike, so that when one would want to climb up the pole, it just makes it much more difficult. I think everyone understands that you can always make it difficult for the guys that try and vandalize it, but if they really want to, it's quite difficult to secure anything.
Okay, thank you. Then the next one. How do the battery cap technologies compare with regards to internal resistance versus state of discharge characteristics? Perhaps a better way of comparing internal resistance.
Kat, I think that one's for you.
Yeah, that's a bit of a difficult one, but look, the self, I'm not too concerned in terms of self-discharge on the supercapacitor, as we are able to use 100% of its capacity. We have actually done quite extensive testing on that unit, where we have discharged units like this for more than 2 years to 100% of its capacity every day, and these batteries have lost no capacity, available capacity on them. And we've even had laboratory tests where we've actually shorted out the terminals, which is quite a dangerous thing to do on your batteries if there's any load on it. But what we do is we discharge it completely. We short it just to see that everything is completely drained, and we've loaded these up to max capacity and kept on using them without any issues surrounding that. So in terms of discharge on the supercapacitor, due to the 100% discharge rate, I can really not see a disadvantage on it.
Okay, thanks. And the next one. So a solar system would be more maintenance intensive than general grid powered lighting system.
Good question. I've been quite busy with looking at the return of investments with regards to that. So yes, you do have some maintenance. With regards to component-wise, if you had to see the amount of components, you would obviously make the assumption that it would be more maintenance. You would obviously do the same for any grid powered in certain form. With regards to the battery and the total return investment, you'll definitely once you go through all the calculation, you'll see that it always depends on the application, one, and two, depending on the availability for a maintenance team to go out. So there's quite a few factors involved in answering the question. I would say yes and no at the same time. It all depends on what technology and battery you are selecting, and the application, and to the location of it. So I would say it's a yes and a no depending on the application.
Okay, thanks. Then here's the next one. This question is being asked by BEKA Schréder of the Greater Tsenin Municipality. Municipalities are keen on solar high mast lighting. This seems to be a problem because, again, space, land will be a challenge when it comes to battery. Do you see us moving towards solar high mast in the near future? Will it be cost effective?
Great question, and something we can definitely take offline and consult you on. Obviously, there's a lot of developments, as you can see, with regards to solar. And so I definitely think we'd like to take it offline with you and consult you specifically on that. But there's always an option, and we definitely like to consult you on that. So we will take that offline.
Okay, thanks. And then we've got a question from Clive Hay. The supercapacitor modules, will they be manufactured to fit into a fitting similar to the BEKA Sol 1? Is there going to be an update on the BEKA Sol 1 and when, as vandalism plays a major role at PRASA?
Okay, so from a competitive point, yes. Gert, you can answer obviously on the SuperCap module. Won't currently fit into the previous or next generation Sol 1. We do have developments at the moment that we're driving through for the next generation. And again, we will take that offline and consult you accordingly. Vandalism is, as you mentioned, is always going to be an issue with regards to the integrated unit, and as you would have seen by the calculations, we still need to make sure that you're getting the correct lights just to illuminate the areas. But definitely, we will consult you accordingly with that. I don't know if you want to add anything, Kurt.
Yeah, just to expand on the supercapacitor module side, look, the suppliers and the manufacturers of these units are quite excited about us introducing this technology into our systems, and we have actually had consultations with them in terms of the shape and the sizes of these things. We have some developments on that, and they are very open to us discussing options in terms of the size and the packaging of these modules. So yeah, there is scope for us to look into that, and it's part of our research and development plans going forward to use these modules more and more effectively in our systems.
Okay, thank you. Then, do solar-powered systems also use gel batteries?
A normal gel batteries, yes, as long as it's a deep discharge battery, because the load is consumed over the full night span. One need to look at that the battery that one wants to use is actually sufficient for a long and deep discharge rating. Standard gel batteries used to be used some years ago in solar systems, but at the moment the AGM batteries are better in terms of environmental conditions, so they give us better thermal applications, which extends the life. I think the risk of using a standard gel is just that your life expectancy might be less than if you were to use the better AGM type batteries.
Okay, thank you. Then we've got a question: what is the physical weight of a 53-watt supercapacitor module system?
Yeah, that's a difficult one. Is it in terms of the complete housing and things like that? It might be a bit more difficult to answer, as one needs to take the the box and the panel and things like that into account. But I can actually tell you that, for example, if you look at a LED system, the LED battery itself adds about 65 to 70 kilograms to your system weight. Whereas if you were to select a supercapacitor, you are looking at only 16, that is 16 kilograms added to the system, which is about only 25% in terms of weight compared to a LED system. I hope that answers.
Does the dimming option come standard with the product or optional extra?
Well, dimming application, it depends on what the wattage of the luminaire is. Some of the higher wattage systems, you do need a dimming profile, but one can look on most of them. We have one or two options, either a higher output or a lower output, meaning more severe dimming during the night. Of course, the more you dim the system, the less energy you use, and that extends the time you can run it, and meaning you can increase the autonomy days and the lifetime of your system if you were to dim more. So there is options in terms of that, but I think the brochure makes it nice and clear in terms of which options are without dimming and which ones are with. And if there's a specific requirement for the site, please feel free to contact our sales team, and we can see if we can adjust it for that specific area to optimize your system output.
Okay, thanks. Are supercapacitors the battery of choice for the future, and why?
I'm the wrong person to ask, actually, because I would say surely yes. Supercapacitors, I think, from what we've seen in using them, they are very good in terms of thermal stability, also in terms of safety. Transport is very safe, or we can transport it in any means that we can. And the technology is expanding exponentially. About every 6 months at the moment, we are getting higher power to mass density on the capacitors themselves. So this means smaller units, units with more power that's out there, and keeping the expectancy or the life expectancy and the cycle life of these units. I think the thing that will be driving this technology is the lifetime of these units and also the warranty. So you can, which makes it the benefit of buying it once, putting it on your system, and you don't need to worry about, you need to save up to replace the batteries themselves, let's say in 3 or 4 years time. So for me, I feel surely it is. There is some development still on the lithium side, where the guys are looking at tantalite as a material. Unfortunately, at the moment, these cells are quite big and bulky, but they also offer better depth discharge rates and life expectancies. But this technology is still in the infancy, and I think it will still be a while until we see that technology in our systems. Also, the systems, the supplier that we are working with, they've had discussions with the automotive industry to try and do tests on electrical vehicles on supercapacitors, as you have longer life expectancies and things like that. Of course, the benefit is you put it in an electric vehicle and the owner doesn't need to worry about changing the batteries ever again. So yeah, I personally think it's the way forward.
Okay, thanks. Then which is more cost effective over lifetime? Consider grid supply, LED luminaire, and PV LED luminaire of same wattage, energy cost and operational cost for full life cost.
I'm just trying to read the question there again. Just give me 1 sec. So effectively, I mean, the question really revolves around the return of investment that we're looking at. So, you know, depending on what the requirements are, you know, we do take the lifetime into effect of the luminaire and all the components based on the system. With regards to energy costs and that, so like I'd rather take that offline with you, and then we can do the specific calculation based on your needs, and we can really deep dive into what the return of investment would be with regards to that, because there's a lot of factors that we need to take into account to answer your question specifically.
Okay, then about the solar panel, which kind of connection is there between the Q cells? I mean, the technology of the panel compared with the available at the market, with what is available in the market.
Well, in terms of panels, of course, we want to offer our customers a good quality, but also a very cost-effective module. So at the moment, we are offering polycrystalline panels as a standard on our system from tier 1 manufacturers. So they usually use up to 5 bus bars per cell on their panels. And yeah, it's just in terms of output, solar panels are developing quite extensively in terms of efficiencies. So at the moment, we've done comparisons in terms of the cost of monocrystalline panels, cast mono cells, and things like that. And it still feels like in terms of the output that you get versus the price compatibility, the polycrystalline is still a good, efficient route to go for our solar systems.
Okay, thank you. When using these PV systems to replace existing lighting systems, are new poles needed to be installed to account for the additional weight and wind loading?
Yes, it is at the moment. The generation 3, because of the windage of the panel, which you are correct, that is the most severe in terms of the load onto the pole. So at the moment, yes, you need to have a new pole installed. Of course, when one goes to the previous generation of Sol 1, due to the low inclination angle, we were able to mount it on existing poles.
Okay, then back to what we discussed earlier, the space land challenge on high mast, or the space land challenge on high mast question asked before, is for panel space actually more than battery space?
Yeah, I think on that one at the moment the best application, I think, for high mast, would be to look at the integrated sort of systems. And due to the advancements that we're seeing, or that I'm seeing on the panel side, the panel sizes are keeping stable, but the outputs are increasing significantly. One can see panels up to 310 watts being the same size as your old traditional 250 watt panels. So one just needs to calculate in terms of the inclination so that you can keep them quite flat in terms of the mast load. So yeah, there is, I think like Grant said, there's some interesting things happening there. So it might be better to discuss it offline.
Yeah, and again, you know, with regards to high mast, you know, obviously it is can be up to 25 plus meters. So we do have to make sure that we can support the load, because you do need to get the light down onto the application, which is really important. So we do have we definitely can, yeah, which is the most important. So it's fine to have something off grid there, but we do need to punch that light down. So we need to make sure that the battery can support the load. So yes, it might be semi-integrated, I would probably say, more than an integrated unit, with a dimming profile, of course, over quieter times. But it's definitely something that we would need to consult on to make sure it's correct for the application.
Okay, then the next one, can BEKA Schréder not make a battery which is integral to the luminaire where thieves cannot see a visible battery?
I know it's CAT is looking at a lot of different options at the moment with regards to that. So, you know, we will consult with battery suppliers itself. So we won't physically manufacture or produce a battery to do that, but we are looking at some advancements. So we can, again, we'll take that offline, but you know, stay tuned. There will be advancements in this area to make sure that we can getting a semi-integrated or integrated unit that looks like a standard, that looks more like a standard luminaire than a solar unit.
Then what is the typical lead times on the largest SuperCap available?
At the moment, unfortunately, due to the lockdown conditions that we are seeing, there is quite a major delay on shipment as these units are coming in from the supplier abroad. So we are expecting between 6 and 12 weeks for shipping these units in. The demand is quite high at the moment locally for these, so we actually need to place our orders on them quite in advance. But yeah, we are trying our best to reduce these lead times at the moment.
Okay, and then we've got a last question here. How do you project the lifespan of a SuperCap battery?
Well, I think the projected lifespan is projected in the same manner as they use on other batteries. The batteries go through what do you call it, a fast charge and discharge cycle. So the manufacturer will cycle these units quite fast over a set period of time. Then one can actually draw a graph in terms of the degradation of the cells over that lifetime. And then usually what one sees is a parabolic shape in terms of the degradation of these of a normal battery. So this was basically done on this in the same method for a supercapacitor over the same time period as you would a lithium or a lead battery. And what the guys actually saw there is it doesn't actually have a parabolic shape, but it's a fixed horizontal line at the moment. And that is how, if you extrapolate this into the future, it's calculated back in terms of cycles, and then you just calculate what typically how many times you would cycle the battery within a year or a day. In our case, it will be one cycle per day, so 365 cycles per year, and then that creates your life expectancy. So on the supercapacitor side, what they've seen is that you do not get a parabolic shape where the battery capacity degrades over the discharge cycle. It actually stays a horizontal line. So, but the guys are still testing those units to see when they will get a reduction in the fall of this capacity.
Okay, thanks. That was the last question from what I can see. Oh, no, wait, there's another question that just came through. How does the inclusion of the battery into the luminaire result in compliance with SANS 475 luminaire performance standard, apart from just the IP rating not being complied to? This performance non-compliance found in other integrated LED luminaire, solar PV panel, and battery product.
Okay, in terms of, I think in terms of IP rating, if one wants to integrate it into the luminaire itself, we as BEKA, we always proud ourselves in that the internal of our luminaires are completely IP rated. So the battery will be enclosed inside the battery, inside the luminaire compartment, which is sealed. Of course, the solar panel cannot be IP rated. So if one would want to also integrate the solar panel onto the luminaire, one would have to make the battery pack itself IP rated battery pack. So these are all factors that we need to consider when we go into the future on the integrated side.
Okay, I hope that answered all of your questions. If not, you're obviously welcome to still email us, get in touch with us. So I just want to thank you all for joining us this morning. Please email us should you require recording of this webinar, but it will also be available on our YouTube channel by the end of the week. So we do encourage you to visit our website or to get in touch with the relevant branch should you require more info. So please still stay online to complete the short poll. There are just 3 questions and we really appreciate your input. Thank you and have a great day further.